Good morning, students. Am I audible? Please ask your friends to join the class. I'll start the class at 9:15. Am I audible? Roll number 4, 30, 46, 41, 26. Okay. Please ask your friends to join the class. Okay, let's start the class. Almost 13 students joined. No, 14 students joined. Okay, let's start the class. Okay. So last class we studied about your thin cylinders, right? So we'll see the derivation for spherical and hemispherical for the thin cylinders. I'm sharing the content. Let me know if it is visible or not. Okay.
Okay, today we
Yes,
discuss
my syllabus
the
is
thin
almost
spherical
completed.
vessel. So we are in
Whatever we
this vessel.
studied will that will be the main portion. Okay. The major part of the syllabus is complete, and we are doing the revision classes of all the topics once again. We'll solve some numericals. Topic by topic, we'll see the theory and we'll do the numericals also. Okay. So the screen is clear. Audio is clear. Audio, video.
spherical in form. If we cut this in this plane, that is the y plane, or you cut along the x plane, or you cut in any plane, will you get
Okay,
the
so
same
let's start
hemisphere
with
again?
the starting.
Okay,
So
today
last
we
class we studied about thin cylinders. We saw derivation for along the. We know in thin cylinders there are two major stresses, right? One is longitudinal stress and another is hoop stress. Okay, so now we'll see the same derivation for spherical vessel. If the vessel is given as spherical, what will be your hoop stress and longitudinal stress? And when you have been given a hemisphere, what will be the hoop stress and your longitudinal stress? Okay, so let's start our class.
discuss the thin spherical vessel. So we have this vessel is a spherical in form. If we cut this in this plane, that is the y plane, or you cut along the x plane, or you cut in any plane, will you get the same hemisphere again? But in the case of cylinder, if you cut in x plane, you get different section, and you cut in y plane, you get different section. But whereas in the case of sphere, will you get the same section? So in this case, along x and y, we have same stress. No change along x and no change along y. Whatever the stress comes, that is called as hoop stress. So if I draw the element here, so is this stress is same as this stress. So this one is called as hoop stress. So on this inner area, that is this area, the pressure will act. And the pressure is acting equals to P multiplied by this area. So this area will be equals to pi by 4 d square. Whereas if you see this area, is it a resisting area? This is circumference multiplied by thickness, and you will get the stress produced along this direction, which will going to oppose this pressure force is along the periphery. So this time your resisting area is pi multiplied by d multiplied by t. So this time we have sigma Fi balance, or we can say pressure force equal to the strength of material, that equal to P multiplied by pi by 4 multiplied by d square is same as sigma hoop stress multiplied by resisting area, that is pi multiplied by d multiplied by t. You can solve this and you can get hoop stress is equal to P multiplied by d divided by 4t. And as per this notation, it is the same along x-axis and is same along y-axis. So same will be equal to max, same will be equal to mean, and therefore its tau max will be equals to 0. So there is no shear stress in this case, because tau max is defined as sigma max minus sigma mean divided by 2. And if we draw the Mohr circle of this one, Mohr circle will be equals to point. That is same value for x, same value for y. So Mohr circle has radius equals to 0. And it's clearly indicate tau xy equal to 0. And if we draw the 3 Mohr circle, then one Mohr circle is drawn, other 2 Mohr circle will overlap, then is this radius will be equals to tau max. Tau max xy will be equal to 0. But what is tau max absolute? Is equal to this value minus this value. This value will be equals to what? 0. This sigma 1, sigma 2. So it's same as sigma h divided by, can get very quickly. Then we will calculate epsilon x. Epsilon x is same as sigma x by E minus mu times sigma y by E. Both are same. And this one is same as epsilon d. It has only one dimension. So it is epsilon d equal to, this is sigma h by E. This is 1 minus, and this sigma h will be equals to what? Pd by 4t.
So for your thin spherical, your hoop stress and longitudinal stress is same. Okay, there will be no shear stress in this spherical vessel. So just remember that in spherical vessel, your hoop stress will be equal to the longitudinal stress and your shear stress will be 0. Okay. Okay. Your maximum stress will be PD by 40 and your shear stress will be 0. This is, they have shown with comparison with Mohr circle. That is not necessary, but you should know what will be the formula for spherical section. Okay, and now they have shown the volume part. What will be the change in volume? Okay, so this is the change in volume formula, but this is not required now. but you should know how this how much change will be in the volume for this kind of section. But the main part is your hoop stress and longitudinal stress. Okay, so this is about the spherical vessel. Now let's see what will be the derivation for your hemispherical. Okay, I'm sharing the another content. Let me know if it is visible or not.
We'll check one by one equation. Yesterday what we had done? Yesterday we got sigma hoop PD by 2t. Sigma L equal to
So
PD.
this one about the hemispherical. Okay, this one is for hemispherical. Is the audio and video okay?
By 4t. Then we have epsilon L equal to sigma L by 1 minus twice mu. So epsilon. We'll check one by one equation. Yesterday what we had done? Yesterday we got sigma hoop PD by 2t. Sigma L equal to PD by 4t. Then we have epsilon L equal to sigma L by 1 minus twice mu. Epsilon L for thin cylinder equal to for thin cylinder, and epsilon V equals to sigma H divided by E into 1 minus mu. And our element is like this. This one is X and this one is Y. So sigma X equal to sigma H. This is sigma H and this one is sigma L. This is for cylinder. This one and this one is same. So sigma X equal to sigma H and sigma Y is also sigma. Let's assume that we have a cylinder with a flat ends. And in this cylinder we are using the plates, and the plates are like this. They are seam welded. Plate 1, plate 2, plate 3. So the cylinder is basically very large. But right now, if the welding is done along this axis. So this welding is done along this axis. So is this angle will be less than 90. So we'll call this angle equal to beta. Or they can have a weld like this also. So this time, if the angle is made with this line is like this. So normally failure will take place along the weld. Will not take place along the metal plates. So I have to investigate this first. So this value will be equal to sigma x, this value will be equal to sigma y, and you are familiar with this type of theta. Theta is made with the vertical plane. So this formula is valid for this. Are they same theta? So you can very well put the value of theta given to you, and then you can solve this. Then you can find out what is the stress along the weld. So this angle will be like this. That is, this one is sigma x and this one is sigma y. And this time we are drawing the plane with reference to this, either here or either here, somewhere here. And suppose this angle is beta. And in this situation, you have to replace your theta by beta plus 90. Because basically we are interested on this plane. Is this value is sigma theta, which is normal to this plane. And this value equal to tau theta. When you have to find out this plane, is that plane is inclined beta plus 90. So that is why you have to put beta plus 90. This beta and this beta is its same beta. If the diagonal is made like this, then you take theta equal to theta. Don't change your equation. If the diagonal is made this pass, then add 90 and solve the problem. Or suppose in the problem, basic stress element is like this. आपका जो element होगा वो ऐसा होगा. So he will never give you this element. Rather than this, he will make a twist on it. And he says that the element was not like this, but oriented at particular angle, like this. And he says that he knows this value, as well as this value, as well as this value. So you can transfer from here to here, as well as we can transfer from here to here also. So this value will be taken as sigma x, then this value will be taken as sigma y, and this value will be taken as xy. And then you can use this formulation and can find out max. If you find out max, mean will be this value. Thin cylinder and hemisphere. So this one is with a hemispherical end. Last time we have flat end. Now one thing is to be noted here is that the design of the cylinder is based on hoop stress. That was equals to PD by 2T. Whereas design of this part is based on PD by 4T. So if you come across this section, that is this section, which is common to both, as well as this entire periphery and this periphery. So at this point, we have epsilon D equal to sigma L by E, that is the strain produced due to thin cylinder. So here this part is basically thin cylinder. And the remaining part is your spherical part. So at this point, we have a diameter strain equal to sigma L by E. And this sigma L is PD by 4T. Whereas the spherical one, we have epsilon D equal to sigma H by E, that is PD by 4T. So there is no issue, that is this one and this one. But if the design of cylinder is based on PD by 2T, whereas design of this spherical is based on PD by 4T, whereas pressure and diameter remain same, material remains same. So for the same value of the hoop stress, that is the same value of sigma allowable, SYT divided by FOS, is the thickness cover for cylinder will be different for thickness cylinder cover for thin spherical. So if I say this thickness is TC, C for cylinder, and this thickness is for TS. So they cannot be same. They must be different. So how the thickness will be adjusted on the basis of the strain produced at this point. So strain produced at this point by the thin cylinder must equal to spherical part. Because if the strain will not be same, then this part will be get elongated and there may be chance of fracture. So at this point we have epsilon D for cylinder must equal to epsilon D for sphere. So we will not confusion. So this one is P multiplied by D divided by 4 multiplied by TC. C for cylinder into 2 minus mu must equal to epsilon D for sphere is sigma H by this is PD by 40. So we have P multiplied by D divided by 2T. Ts. Is it 1 minus B? For this case and this case, the pressure remains same, diameter remains same, 4 is constant, that can be taken common, Ts will shift to this side. So Tc is get multiplied by 1 minus me, and this is divided by 2 minus me. Both sides actually I have to divide it by E. I have to divide this also E by E. That will cancel. This E and this E will be cancelled out. As far as steel is considered, value of mu is normally equals to 0.3, very close to 0.3. So if we put this value 0.3, 1 minus 0.3 is 0.7 and 2 minus 0.3 is 1.7. So you can find out this ratio. This ratio come out to be 1 by 2.54 approximately. What does it indicate? That the thickness of the spherical shell multiplied by 2.4 must equal to the thickness of cylindrical shell. If you take mu equal to this value, and if you consider any other value than this, then the value you can very well find out relation between the thickness of the plate used for hemispherical part and the thickness used for thin cylindrical part. Suppose we are given here a tank with a flat end and cylindrical tank. So naturally we are doing the welding for this, and whatever the liquid or gas you are going to store inside this one must be checked for leakage. So what is the one simple test? You fill this with liquid. If the volume of the tank is known, so you can add the water. If the mass of water required is density multiplied by volume of this vessel. So if there is any leakage, so leakage test can be done. But if the vessel is subjected to pressure, then you want to check that pressure, then you must create the pressure inside this one. That pressure can be created by pumping the more liquid inside this one. So if you add delta M water inside this one, which was excess than its capacity, then every water enters inside this one, will it pressurize this tank? That if you have this capacity only, that is this volume multiplied by rho and this amount of water you add inside this one, you can just able to check the leakage. But if you want to check the pressure, then you must add extra water inside this one. Any extra water added inside this one, if added, you require a device that is called as pump. So what you do first, you have to pressurize the water first using pump. So if you pressurize the water using pump, in that case we have a definition of bulk modulus for fluid, which is defined as change in pressure divided by change in volume divided by volume but minus sign. And the second definition is change in pressure divided by change in density divided by density. This is beta. Beta for water is approximately 2.07 gigapascal, 10 to the power 9 pascal. So what I want to say is that if you want to add more water in the same volume, so your next mass will become m plus delta m, but your volume remain constant. So your only chance is that the delta density must increase because your volume will not change. So you must increase the density. To increase the density, we'll pressurize the water using pump. And can we find out the new density as per your calculations? So temporarily I will neglect the minus sign here. Then how much extra volume I require, that I can find out. So this is dV by V equals to dP by beta. And how much extra volume I required is dV is equal to dP divided by beta. What I want to claim is that because the water is pressurized and since it was elongated, it means that we have this type of stresses are coming. But the water itself will be going to make extra pressure on this one. So again the volume will increase. That is, the dimension will further increase from this point to this point again. It means that extra volume to be adjusted inside this fan. So how much total volume is changed? First is due to pressurization of thin cylinder, is the volume change will be equals to sigma L by E into 5 minus 4 times V. So delta V from this one we can calculate. This is just due to pressurization. If you just pressurize this by gas, then the tank volume will be changed by sigma L divided by E multiplied by V multiplied by 5 minus 4 times, this one is mu. And this much is the change in pressure because of the compression of pump. So that volume is extra volume, so additional extra volume is to be adjusted here. This is change in pressure. So this is dP multiplied by volume divided by V. So can we find out how much exact volume is to be added? So if you add this extra quantity of water inside this one, the test can be done for desired pressure equal to P. So this is justification for this part. If the fluid is used as the pressurization medium, the fluid itself will change in volume as the pressure is increased. And this must be taken into account when calculating the amount of fluid which must be pumped into the cylinder in order to raise the pressure of a specified amount. But when you pumping it, in that time, before you pump it, that pressure was atmospheric. And when you pump it, then it becomes pressurization. And because of that pressure, the vessel itself will expand by volume equal to what? Delta V. So this delta V plus this delta V, you have to find out total volume to be added. Now recall that how we had done the derivation for the longitudinal stress. For longitudinal stress, I think we have shown this force equals to P force, and this P force is equal to pi by 4 d square and is balanced by this force at periphery, which was equal to circumference multiplied by thickness. And therefore we get an equation of sigma L equal to sigma H by 2. Just verify this equation. Is it a correct equation? So we have pressure and we have this force, that come out to be sigma L equal to PD by 40.
So that's what about your thin cylinder formulas for your some spherical surfaces and hemispherical surfaces. Okay. In the next class, we'll see some numericals based on this formulas, hoop stress and your longitudinal stress. Okay. So write your roll numbers in the chat box, please. Just remember the formula to solve the numericals, okay? Don't leave the meeting, okay? I'll call out the names. Just check if your name is there or not. Four, 1, 12, 30, 47, 14, 24, 29, 26, 11, 3, 40, 33, 20, 2, 9, 44, 23, 21, 22, 8. Anyone left?
Ma'am, 32.
32. Please write your roll number in the chat box. 9 was the... Okay. Anyone left? 25, 43, 32. Okay. Anyone left to write? And go through your previous class to see the to just remember the formula. Okay. In the next class, we'll okay. 43. One more roll number. 43. Anyone left? Please write your roll number. Okay. So go through the formula. Okay. Go through the notes I have provided in the class. The next class will solve some numerical and you will tell me the answer. Okay. I won't share the answer part. You will tell me the answers. So be ready. Everyone be active. I'll mark the responses of yours, everyone. Okay, so go through the formula in 10 minutes. I'll text in the group to join the next class. So just revise. Okay, revise your notes and revise your class so that you can solve numericals based on that. Any issues, any doubts from today's and previous class, let me know in the chat box. After doing numerical today, then we'll move to thick wall pressure. Then we'll see the shear force and bending moment problems also. Okay, I'll provide the questions solved by yourself and you need to present. From the next classes, you need to present in the class. Okay, I'll give you some numericals you solve by yourself and you have to present in the class. I'll make some do one thing. If CR is in the participant list, make group of section A na? Make equal amount means in one group all the groups should be of equal amount equal number of students. Make groups. Okay, make groups. Then I'll assign one problem on shear force and bending moment to each one of you and you have to present the solution from the next classes. Okay, after this thick cylinders we'll move to the shear force and bending moment. Okay, and if any topic I missed out in the revision class also let me know. Okay, okay then join after 10 minutes. Okay, I'll text in the group then join. Thank you.